So now, in this video we're going to look at this power meter, basically. So yeah, it's Drock. I bought this a long time ago, and I attached ferrules to these wires and plugged them into the unit there, and we can work from 6.5 volts up to 100 volts right there. So it just measures the voltage and the current. We can go up to 20 amps of current according to the back there. So there you can see the input voltage are these middle two right there. So my longer wire, for whatever reason, probably shown in a video a long time ago. And then the load comes across the outside. So we got negative, positive. So you can't tell that on the front, but I already got red and black wires on there so that I know what they are. So we can't do 5 volts. But my power supply is already set to 9 volts from the last circuit I did. So that happened to just kind of work out pretty well right there. It's a 555 timer. Output's going to be high till I press this button. Now the output's low when I get a good press, and back to high. So single button can flip it back and forth instead of having to use two. One for setting the output high and the other for setting the output low. But in any case, we don't really care about that in this video. So for this video, first we are going to, and this is one reason why I'm doing this video. When I was practicing this, it was easier to wire this up because I didn't think we kind of got to get the camera catching all that. But now we're going to put the supply voltage to the meter there so we can see what the meter displays. So we got positive to the red wire and then negative to the black wire. Trying not to short them. If we do short them, okay, we need to face that way. There we go. That will actually help. So, we can see there, I got the power supply at 9 volts. It says 9 volts. No current is flowing right now. Power is simply voltage times current. So if we had 1 amp there, then it would be 2 watts. Now it would fall a little short. I don't know. Oh, I'm touching the power supply. If you bump the power supply, it cuts power briefly. But yeah, 9 volts, 1 amp would be 9 watts. 9 volts, 2 amps would be 18 watts, and so on. You simply multiply it. And when it comes to watt hours, so if we had a 1 volt and then 1 amp, that would be 1 watt. And after an hour, it would say 1 watt hour. If we had 2 volts, 1 amp, then it would be 2 watts. And after an hour, it would say 2 watt hours with 2 volts, 1 amp, which would be 2 watts. After 2 hours, it would be 2 times 2 for 4 watts. Hopefully that makes sense. And I think this is the reset button, if because the watt hours keeps adding up over time. So I think that resets it back to 0, I believe. So what I decided, if I do like a breadboard, I have these jumpers. So these we probably want to limit current to 1/2 of an amp because these are pretty small wires right there. I think they can handle 1/2 of an amp pretty well. I could be wrong though. So yeah, I'll plug that to the positive side and plug it into the red rail right there. The red rails are connected on both sides, and the black, they're actually blue rails, but with the black jumper. I got them connected as well. So to make sure we don't short circuit something, but the power supply does have short circuit protection. First I'm going to plug this into the breadboard, and then I'm going to plug it into our meter there. So blue LED lit up, and yeah, so we got 9 volts, about 10 milliamps. So this isn't as you can see we got like 11 milliamps right there. So we can go to the single milliamps, so thousandths of an amp. On this one we cannot. We can go to the tens of milliamps or hundredth of an amp right there. But yeah, it is about 10 milliamps approximately with the blue, and with the red it's like 9. That's still saying about 10 milliamps of current right there. So I think this is relatively accurate. It's probably meant to be measuring closer to the amp range. So even at this low unit. So we would have to do this for probably about, we can't even get a wattage rating right there. but when it comes to the wattage, we would have 9 times 1, so it'd be like 0.09 watts approximately. And so what would that be? 0.09, so basically 0.1. After like 10 hours, maybe 11, 12 or something, that would say 1 watt hour. Hopefully that makes sense. But in any case, this is meant for measuring like higher power stuff. So I don't know for sure what we get. Again, I bumped the power supply. That's why the voltage dropped down. But yeah, that's how easy it is to use this unit. Again, I wired up these wires. So I had, I believe that's 16 gauge right there, stranded wire, and ferrules. So that's a ferrule there. So it's just stranded wires, a bunch of just individual wires. This slides over it, and there's a little crimping tool that makes it a little square shaped, but they're also kind of wavy shape as well. And they do a pretty good job going into screw down terminals right there. This may be the largest wire I can put into this particular screw down terminal there, but there's higher power units that can accept bigger ferrules right there. So the bigger the wire, the more current it can handle. So when it comes to wire size, it's mostly how much current it can handle. When it comes to the voltage, I believe if it has a voltage rating, that is for the insulation, I believe, to you know, keep it contained within there. If you like touch them both at the same time or something, if the insulation's too thin, you might get a shock, you know, when it comes to coming across. I believe that's the primary reason for voltage rating, is how well the insulation can prevent wrongful electrocution for the most part. But when it comes to how much current can flow through, definitely the size of the wire. Larger wires can handle more current. So voltage travels over a long distance better than current does. In fact, that's one reason why I'm looking at this unit there, to look at stepping up voltage so that it can travel longer distances. And so you know, we're going to want to keep track of how much voltage and current we got at different parts of the circuit, because as you raise the voltage, you know, you'll have like a source. It'll provide a certain amount of voltage and current, but you want to transfer a higher voltage. It converts some of that current into voltage. So ultimately, traveling through the wires, you'll have a higher voltage, but at lower current. Ultimately, it'll be about the same power. As we saw before, that's voltage times current. So you want to keep it as close to that number as possible. There are losses. But yeah, in any case, I rambled on long enough. Hopefully you found it interesting. If you never saw one of these units before, they're pretty common, pretty easy to find. Again, I bought this a long time ago. There's probably, you know, better option, but I think it was one of the best options for me at the time. Drac made this one, but again, a long time ago, they might not even sell it anymore. So thanks for watching. Make sure you check out one of the other videos I post on the screen, and check out the links down below. They all help out a lot.